Hello, and a warm welcome to everyone. We would like to wish everyone a good morning, a good afternoon, or a good evening, depending on where you are in the world. My name is Samantha from Safeopedia, and here at Safeopedia, it is our mission to support the EHS professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I'd like to extend a huge thank you to all of our dedicated safety professionals for the great work they do on a daily basis in keeping our workplaces and our workers safe. Just a reminder, this webinar is being recorded and we will send out a link to recording to everyone in a few days. So keep an eye out for that. We're also going to have a Q&A with Bob Henderson of GFG Instrumentation at the end of this webinar. So get your questions and your comments for Bob ready. Today, we are proud to present gas detection for industrial manufacturing. The Safeopedia webinar has been made possible today by GFG Instrumentation Inc., a preferred manufacturer of AD Safety Network. AD, together we win. It is now my pleasure to welcome back Bob Henderson. Bob will be discussing the common challenges of maintaining a gas detection program in industrial manufacturing setting, including managing compliance, personnel, and products. I'm excited to have you all sit back, relax, and enjoy this presentation. With that, Bob, let's jump into it.
Well, Happy New Year, and it's good to be back. And boy, is this one of my favorite gas detection topics. It definitely involves fixed gas detection. GFG instrumentation, we actually, on a worldwide basis, do more with our fixed gas detection products than our portables. Don't get me wrong, I love portable gas detectors. But today gives me a pretty good time to jump in and spend a little more time than usual on the fixed system options and issues. But whether it's fixed or portable, the common drumbeat throughout my presentations is when you're thinking about gas detection, the best instrument for the application needs to be a function of sensing technology, a function of the manufacturer's purpose, what the design was created to do, and your needs. So let's see if we can't do a good job or a beginning of a good job to figure out what your gas detection needs actually are. Manufacturing is a really broad category, so this is really just the starting point. For manufacturers, the gas hazards can be generally present or they can be present associated with specific activities like confined spaces and confined space entry. Hazard assessment is a critical point, a starting point in deciding what you need and figuring out what to do. So let's talk about how you figure out what your needs are. Start with a detailed assessment of activities and risks that involve atmospheric hazards. If you've never sat down and actually listed them all out, sometimes it can be a shock. Drill down to make sure you understand what is most important and make sure to determine whether or not you're meeting all requirements. Requirements change. If your corporate policies follow the TLVs, or if you live in a state where the exposure limits for toxic gases are tightly tied to the TLVs, the exposure limit for benzene dropped all the way down to a TWA of 0.02 for the parts per million for the TLV for benzene effective last year. For 2023, you didn't have that requirement. For 2024 and onwards, you do. So you can't figure these things out once and forget about them. You need to keep your requirements updated and review your program periodically to make sure that you're still in conformity with requirements. And that helps to identify where you need to make improvements. And remember that gas detection is not limited only to safety. You also have facilities protection, you have notification issues. There are a lot of things that go beyond just immediate safety of the workers who are engaged in their activities on site. And these issues are absolutely not limited to portable instruments. The kind of activities that we're talking about for gas detection and atmospheric monitoring, personal exposure, confined space, construction related activities can also often introduce atmospheric hazards, hazmat, emergency response, hot work where you're deliberately introducing a source of ignition into the working area, and manufacturing activities themselves. The products that you're producing can, in some cases, introduce atmospheric hazards into the workplace. So manufacturing activities include production, um, process control, facilities safety, industrial hygiene compliance, community monitoring issues such as fence line or nuisance odors, regulatory requirements. And it's not just OSHA we're talking about for the manufacturer. You also need to make sure that you're not releasing contaminants that exceed EPA requirements. You also have disaster response issues. You need to know what you're going to do and take provision as to what you would do in the event of floods or leaks or spills or accidents. And of course, anytime you've got construction going on at the site, that can introduce new hazards. Sometimes the materials themselves that you're working with are a source of contaminants that need to be measured. Resins, sealants, polymers, solvents, degreasers, these are widely used. Refrigeration gases, ammonia, propane, freons, halocarbons, nitrogen. If you have a leak or the gas escapes into the area where unprotected workers are engaged in their activities, you need to be on guard and do something about that. Processes that are used to transform raw materials into finished goods often involve chemical reactions, curing, drying. All of these activities and procedures can be the source of atmospheric contaminants or hazardous atmospheric conditions. Um, there are a bunch of different chemical reactions that can go on in the manufacturing process. Each of these is going to be associated with the potential presence or generation or containment of specific contaminants. So you need, as a safety manager, to really be aware of all of the possible outcomes, both when the process is going correctly and when the process goes out of balance. Some of the absolute worst disasters ever in the chemical and atmospheric hazard world have occurred when the process went out of balance. Probably the most famous example, the worst example I can think of, was the Bhopal methyl isocyanate incident that killed so many people in India. So do make sure that you truly understand what processes are going on and what effect that might have on the workplace atmosphere that could affect your workers. Natural processes that are famously able to create dangerous atmospheric conditions include fermentation, that produces CO2 as well as can lead to oxygen deficiency, decomposition. If something is subject to bacterial or microbial decomposition, you have all sorts of things that are being put into the atmosphere. Oxidation, rusting, can lead to atmospheric depletion of oxygen and other problems. And of course, confined space is not the only source of atmospheric concern at a manufacturing site, but it is an important one. So do make sure that you're following your program guidelines, that you update your program requirements accordingly, when your procedures change, when the dangers change. Be on the lookout for hot work and activities like scraping, mucking, using paints and sealants. When that's going on in a confined space, you definitely are increasing the potential dangers. Some of the other things that cause atmospheric hazards at manufacturing sites, you have battery charging, which can generate hydrogen. You have combustible liquid cabinets. You have gas storage areas. And as I mentioned before, there's often the potential for spills and leaks. You also might have fueling stations where you're filling tanks in portable equipment or tractors or carts with propane or hydrogen. You have combustion processes that are going on often. Stack gas, SO2, acid gas, oxides of nitrogen like nitric oxide and nitrogen dioxide, carbon monoxide, carbon dioxide. These are all dangerous contaminants, and frequently you need to install protective measures to keep track of concentration or to keep a buildup from occurring. You have engine exhaust. Similarly, you have CO, NO2, NO, CO2 in the exhaust that could be a concern. Sometimes you're deliberately creating dangerous atmospheric conditions during the manufacturing process. The manufacturing process might include nitrogen purging, use of curing ovens under a nitrogen purge, inert gas actuation. That's something you see repeatedly or very commonly at steel mills, aluminum mills, and foundries. You also have shielding. For instance, hydrogen is used to shield dynamos and generators. Just this morning, one of our customers we've been helping with portable instruments is dealing with a leak of hydrogen at a, I won't give too many details away, at a power generating station where they are losing a lot of high concentration hydrogen into the working area. And there was a sudden desperate need to be able to measure it in fairly high concentrations. There's a lot of hydrogen out there when you actually look around for it. Um, One of my favorite resources to help understand your atmospheric monitoring needs and define the objectives is an AIHA white paper. That's American Industrial Hygiene Association white paper, which is free for you to download. They allow even non-members to download a copy. And we would be glad to help you do that. The name of the white paper is Establishing a Process for the Setting of Real-Time Detection Systems Alarms. And what we did in that white paper was go through a formalized process for figuring out what you need. Sometimes it's a pretty easy process. For instance, confined space regulations are pretty clear with what you need to do for atmospheric monitoring for confined space entry. But outside of confined space entry, especially just for general and fixed gas detection systems at a manufacturing site, it's hard to find a lot of good guidance. This white paper really provides that guidance. It helps you understand the monitoring target. Some of the concerns that you need to address are the operability of any instruments, be they portable or fixed, in the environment where they are installed or deployed. What are the environmental conditions and how might that affect your ability to use the equipment or for the equipment to be properly operable? Human factor considerations, alarm information, what you're going to do with that information, how you verify the instruments meet certification requirements that you might need to deal with at your site or for that process or procedure. It's a nice formulaic way to make sure you haven't missed something along the route to a conclusion as to what you need. Gas detection requirements, again, are not limited to portable instruments. When the hazards are generally present or associated with specific activities, like confined space entry, often gas detection solutions are going to focus more on portable instruments. So if you have H2S anywhere on site, someone entering the site is going to have a personal H2S monitor at a dead minimum. You can't get in the front gate in that case without it. When the hazards are associated with a specific activity, like confined space entry, then the portable instruments would be assigned, or you would take them out. You would use them according to your program requirements. But when the hazards are present in areas of the site which are not strictly governed by entry and exit requirements for people, often the focus for atmospheric monitoring shifts from personally assigned portable instruments to permanently installed fixed gas detection systems, where you're moving to a 24/7 approach to keeping track of the atmospheric hazards. Don't be afraid of considering fixed system solutions. Many of the common solutions for these problems are based on small standalone single point systems, or small systems with 1 to 4 gas detection points. We call the point of the equipment that is installed at the point of detection a gas detection transmitter. That includes the sensor and the associated electronics that are right there at the point of detection. You don't have to have an elegant large controller that's capable of taking the input from hundreds of transmitters. A transmitter by itself with a horn and strobe makes an excellent single point standalone system. That may be all you need. You can link the transmitters together into a larger system, or you can leave them independent and install them in locations where you need them. And you may satisfy all your objectives without a lot of complexity. When you are talking about a fixed gas detection system, especially a larger system, it can be complicated, you betcha, but you have a lot of friends out there. Gas detection equipment manufacturers are very good to work with. And of course, AD distributors, that's what they do. AD distributors tend to be very expert with, or at least some of their people are highly expert at gas detection issues. They have multiple lines to pick from. They have a lot of knowledge in this area, and also they know who to ask if they need help. Manufacturers have that help. We are just waiting for the phone to ring or the email to drop from our potential and existing customers who need help. It's a central part of what we try to do as a manufacturer. Make sure you understand company policies and procedures if you are talking about fixed gas detection solutions. Are the fixed system decisions going to be made by a third-party design firm or engineering firm or a contractor? Are the systems made by management at the facility? Are they made at a corporate level someplace else? Are there any currently open projects that you're aware of, maybe not only at your site, but at other sites where you might want to coordinate the decisions? try to figure out who needs to be involved in the specification and evaluation process. Sometimes this includes union personnel, sometimes it's safety, sometimes it's facilities, sometimes it's process. Also, make sure you understand or figure out or decide who's going to be responsible for ongoing routine maintenance and calibration and the things that go into having a fixed gas detection system and making sure it remains operable. The best way to proceed at an early stage, and every gas detection manufacturer has one, is get their fixed system, get a copy or download a copy of their fixed systems application questionnaire. These tend to be very simple documents with just the basic kind of information that the manufacturer needs, so we don't waste time talking about a product that is not the product that you actually need. Manufacturers, as you're going to see in just a minute, have a lot of options with different ways that we can go with fixed detection system components and detection technologies. There's a lot of variations. One of those variations is going to be the one that you need or the one that is the best for your purpose, but figuring it out can be a little bit complicated. Coming up with a quote, we definitely need some information. We don't want to go down the wrong rabbit hole. So fill out that questionnaire. If any of the questions seem difficult or you don't know how to answer, talk to your AD distributor, talk to the manufacturer. As President Bush once said it, go to the Google and ferret out the information yourself. It's what I do. I go to the Google constantly. But anyway, try to capture some of the information at this simple level with the questionnaire, and you'll get to a positive conclusion a lot more quickly and come up with the best approach to a long-term solution to your atmospheric monitoring needs. So fixed gas detection systems, you need a few vocabulary words, and this will help you fill out those questionnaires as well. Most basically, a fixed gas detection system includes, as I mentioned, the gas detection transmitters. That's the part of the system where you have the sensor, the associated local electronics. You can have a display, you can have a horn, you can have relays right there at the sensor, but everything is located near or at the point where the atmospheric hazard exists. So that's the transmitter. The controller is the brains of the system, and that can be somewhere else. You can have a controller for one detection point. You can have a controller for many detection points. The controller can be immediately adjacent or next to the transmitters, or it can be a long ways away. Sometimes it's even in, you'll have one controller at the site where the detection is occurring. We've got one of our customers in Mexico. We have two different steel mills. One of them is in one city, one of them is in a different city, and the corporate office is in a third city. And the corporate office needs to be able to see real-time readings from all of the points of detection at all of the facilities in their safety network. So what we do is we're going to wind up distributing transmitters, controllers, and programmable logic controllers and distributed control systems in a way that the information, the real-time information, is available exactly where you need it in real time when you need it. And we'll talk a little bit about how we do that in just a second. And sometimes, again, a lot of the time, the answer is not an incredibly complicated large scale system. A lot of the time, the answer is a simple standalone system where it comes in a box, you terminate the system to line power. I don't like myself, I avoid, or at least I talk to our customers about the advisability of plugging the equipment into a wall socket, but that can be done. That's one of the options. I like to permanently connect the system to line power in a way that people can't unplug your life critical safety equipment to plug in a vacuum cleaner at 2 a.m. But anyway, for a standalone system, installation can be as simple as terminating it to power. Bingo, bango, and you're done. Or the installation can take a lot more effort, and you'll have to figure out how to manage that and who is going to handle it. Um, Again, here are some examples of a fixed system gas transmitter. And you can see how many variations there are. I'm not going to spend an infinite amount of time going over each variation. I just want to generally acquaint you with the options. You can have a gas transmitter that doesn't have a display or does not have any controls where you can directly do things through an interface with the transmitter. So you're hooked up to a controller or a programmable logic controller or a computer somewhere else. If you want to see the readings or what's going on, you're going to have to look at that controller or computer screen to see the readings. But there are a lot of situations where the transmitter is located in an area where people can't see it. Even if you did have a display, it would not be possible for the people to see the readings. So maybe up in a ceiling or in a vent line or in a place where you don't have visual access, a blind transmitter is a good choice. That's one of the things that you define as you go through that selection process, those objectives in the AIHA white paper. Or you can have a transmitter that has a push button interface or a magnetic interface. Another part of the decision tree is knowing the hazards associated generally with what's going on in the area. If it is an area which is characterized by the potential presence of combustible gas, then it is a hazardous location and it requires a product that is certified for installation in an area of that level of hazard. If it is not an area that is characterized by the presence of combustible gas, then we would normally think of it as an ordinary or a non-hazardous location where the instruments still require an appropriate certification for electrical safety, comes from the same laboratory, different certification, still might be CSA, UL, DECRA exam. So it's still a certified product, but since it's not being used in a hazardous location, it's being used in an ordinary location. That's the certification that it carries. But you have to figure out what certification is needed, and you don't want to go overboard if you don't have to. One of the most expensive aspects of acquisition for a fixed detection system is the wiring and conduit that you might be required to use to install the system. If you have a hazardous location requirement, For combustible gas, a class 1, div 1 hazardous location, in a lot of cases, the solution may depend on the use of an explosion-proof transmitter where the electronics and the potential sources of ignition that you have with the electronics are made safe by using an explosion-proof junction box or housing. Now, to maintain the explosion-proof protection, you have to run any cabling from the junction box back to a controller or PLC. You're going to have to run the cabling through certified explosion-proof stainless steel conduit. And guess what? In many cases, the price of the system, two-thirds of the price of the system, comes from the installation of the stainless steel conduit and stringing the transmitters together with the controller. So if you don't need that, don't spend money on it. But if you do have a hazardous location and you have that requirement, then that's your solution. Now, there are two protective methods that you can easily use or you can pick from with your transmitters. Manufacturers, as I mentioned before, have more than one product that they can steer towards depending on your needs. One protective method is to deal with the hazards by containing the hazards in an explosion-proof box and a junction box and conduit. Another approach is to design the product so there is no electrical energy that is around to be released under any circumstances. That's how we design portable instruments. I'm sure most of you have heard the term intrinsic safety for portable instruments that are used to measure combustible gas and other hazards. Well, we have the same option available for fixed gas detection gas transmitters. So here's an example of an intrinsically safe combustible gas transmitter where, because there is no possibility of the release of enough energy to be the source of ignition for the combustible gas that might be present, I don't have the same requirements for super expensive certified stainless steel explosion-proof conduit. I can use electrically compliant conduit that is a whole lot less expensive and easier to install. So those are your options there. If you are talking about where you situate the transmitter, it depends on how the gas is getting into the sensor, and you have a couple of different options. You can have this is a family of gas transmitters. In our case, we call this family the DREX family. It started out targeting the semiconductor industry, but it's become very popular in general industry and among manufacturing customers for GFG as well. But anyway, what you have in the DREX transmitter below the others, you have the sensor installed in the housing itself where it is operating on a diffusion basis. So the gas enters the sensor as a function of being present in the atmosphere near the sensor or in which the sensor is located, and it's all a natural diffusion process. Another method of getting the gas into the sensor is to take the sensor cassette out of the unit and put it out on the end of an extender cable. So now you have a local display, push button controls, but the sensor itself might be in an awkward place that you can't easily get at and would not be able to see the readings. So that's another way you can go. Yet another way, the unit in the center has a built-in motorized sampling pump. So we are hooked up to an inlet tube and an outlet tube. The outlet tube can send the sample after we've measured what's in it, either up the chimney, through a filter bed, or back into the process line where we took the sample to begin with. And that's called an extractive type of sampling system. Now, to be able to measure even more kinds of gases than we have sensors available for, we can sometimes process the gas that's coming in. The unit on the right is a pyrolyzer, and the way that we use the pyrolyzer, I'm sorry, the unit in the middle is the pyrolyzer. The unit on the right is the pump equipped DREX. And before the sample gets to the sensor in the unit on the far right, it goes through the pyrolyzer. And as you can see, this is designed to measure NF3, nitrogen trifluoride. There's no electrochemical sensor available to measure NF3, but we're still able to measure it. We take it through the pyrolyzer where the molecules are cracked apart and turned into HF molecules, which we are very good at measuring. So we measure the NF3 by breaking it apart into a different molecule, which we can measure. And since we get 3 molecules of HF for every 1 molecule of NF3 that goes into the system is really very sensitive and highly accurate for the gas that we actually need to measure. So that's an example of 3 different ways that we can configure the transmitter. As it turns out, these are all designed for use in non-hazardous locations. If we want to measure the same molecules in hazardous locations, we can go back to the explosion-proof protective concept or transmitters that are based on the intrinsic safety protective concept. The kinds of technology that we have available for fixed gas detection, we've got a lot more options than we have with portables. So it really is very important for the manufacturer to understand fully what you need to accomplish because we have so many ways that we can configure the system. We're able to measure hundreds of different types of gases and contaminants and analytes. We have a lot of different types of sensors. The transmitters mostly tend to be designed for flexibility where you want to measure a different gas, you plug in a different sensor. So they depend on smart sensor designs, and control of the gas sensing technology is actually really important. We pride ourselves on the sensors in GFG products. We make most of our own sensors, and they're based on proprietary designs that we've spent a lot of energy since the company's foundation in 1961 coming up with. Fixed system controllers, the brains of the system. Here's a popular example. This is a 1 to 4 channel system. It's very easy. You just hook it up to the number of transmitters that you need to control. It comes in a box that goes on the wall. The system has a built-in high-intensity horn and strobe. So all you have to do is mount the transmitters, hook it up to line power, and you're golden. Another type of transmitter is a PLC type controller, a programmable logic controller. Here, this is what we would call a DIN rail mounted design. A lot of your electronic equipment, control equipment at a manufacturing site is going to be mounted, everything from thermostats to gas detection controllers on something that we call DIN rail. DIN rail looks like a little miniature HO scaled railroad tracks. And you've got track after track mounted horizontally in a cabinet. And these are an industry standard size and format. And equipment like this particular controller sits nicely on the DIN rails. It makes wiring and mounting the equipment that much easier. This would be an example where we can accommodate up to 16 transmitters and directly wire them back to the controller by a hardwired analog connection. So here, the current that is used to operate the electricity that's used to operate the transmitter is also used to provide you with a reading. And the signal ranges between 4 milliamps and 20 milliamps. For an LEL sensor, a reading of 0 would be 4 milliamps. A reading of 100% LEL would be 20 milliamps. When the system is offline or there is a problem with power, the output will drop below 4 milliamps, and we know that is going on immediately. And we might have another method of putting the system in calibration mode. That also is going to have a special signal that is outside the normal 4 to 20 milliamp range. The whole idea of a 4 to 20 milliamp analog connection is an industry standard approach that is used not only for gas detection equipment, but all kinds of other equipment that might be present and used for measurements on site. Besides the analog 4 to 20 milliamp connections that you have with the controller can also talk to other controllers or modules or equipment by means of a digital signal. And you also have the option, instead of using an independent hardwired connection for each transmitter, you can use digital communication means to put every one of the transmitters on a common bus line. Here would be an example of that. The controller has 2 bus lines plus a third bus for the system, and you can easily build amazingly complicated systems and scale the system up as large as it needs to be scaled just by using these digital communication methods. And from the controller, you can always take that information for all of the transmitters in the system to a central computer or PLC. And we have various levels of sophistication and size in terms of how many transmitters that we can handle with a particular controller. This one is capable of handling up to 128 transmitters plus additional modules, be able to plug it into additional controllers. If you need a 500-point system, it's pretty easy to get there. Here's just to show you what it looks like. Here is a 16-point system in a cabinet with a touch screen PC built into the door. Here's a 32-point system in a floor standing cabinet. And here's an even larger 50-point system. So you can see how readily these systems can be scaled up. Now, whether it's fixed or portable, my suggestion is if eventually it is going to come down to price. Price matters. But don't base the entire conversation and selection process on the initial purchase price. There is more to the ownership of the system than what you pay for the gas detection components that come in a couple of boxes. You have to, or you should consider for fixed. Your cost is going to include installation. It's going to include ongoing maintenance, calibration. For the portables, it's going to include things like sensor replacement, the requirement to replace sensors frequently or less frequently. All of these issues can drive the true cost of ownership of that product. So try to figure that out and ease into the pricing part of the discussion with your suppliers a little bit later in the process. Don't open with, it's my advice anyway, as a manufacturer myself, you don't want to open with price because that can easily lead to a bad decision. I cannot tell you how many times I've seen customers settle on the wrong product and a couple of weeks after getting the product, they're filled with remorse. Hopefully, doesn't happen with GFG, but trust me, it does happen. And you want to identify the cost of ownership issues that are going to affect you depending on what you buy. If you're spending too much money on your current equipment, you should figure out what's going on. Are you being charged a high monthly fee for reports and factory support? I know of some of customers that we have taken over from other manufacturers where they were spending $1 million plus a year for a manufacturer contract that was generating email messages and automatically sending them replenishment supplies of calibration gas. It's nice when you have that going on. Whether it's worth $1 million, I'm not sure. It's always worth $1 million. When it is, it is. But make sure you understand what you're spending money on and will be spending money on in the future, and make sure that it's a worthy expense. Do you have a lot of sensor failures? If so, what kind of sensors are failing? Do you have battery problems? Are you responsible for calibrating your own instruments, or are you farming it out? Are there any special contaminants or circumstances that are giving you grief? All of these drive your cost of ownership. And sometimes customers don't have a clear understanding of what's going on at different levels in their organization. If you're living in a corner office, well, I would suggest leaving the corner office once in a while and walking the floor and drilling down and see what's really going on. If you want, of course, if it's something that you want someone else to take over for you, many to most AD distributors have factory authorized service centers for the product lines, the gas detection lines that they represent. So you have a choice. You can go to the manufacturer, you can go to the distributor, you can go to a third party calibration service. You've got a lot of folks that you can work with depending on what you need or want. Make sure if you're thinking about changing the kind of instruments that you're using or expanding your fleet of instruments, that you think about all the things that we've been discussing. Requirements change, new products have better features often, better or lower cost of ownership. Things are evolving pretty rapidly in the gas detection world, and your gas detection suppliers are really happy to talk about what's new and wonderful. That's what we get out of bed in the morning to do. Make sure, again, that you keep pace with regulatory requirements. Used to be that nobody would think about any more sensors than a two sensor design. When I got into gas detection 40 something years ago, the most sensors that could be tucked into the same instrument. We're an oxygen sensor and a combustible sensor. And we thought that product was amazing. And then you saw a shift to three sensor instruments that included usually H2S. And then it was four sensors that included CO as well as H2S. Nowadays, we have up to seven channels of detection built into the same instrument. So we could have a combination of a typical oil production site combination nowadays is often a six sensor configuration or a six channel configuration where we're measuring oxygen and LEL and PID for VOC gases and vapors, CO and H2S, because for confined space entry and normal purposes, it's something you run into very frequently. But there is an acknowledgement that if you have the presence of H2S and you're doing hot work, you have an excellent chance of generating SO2, and that takes us up to a sixth channel of measurement. So for these users, that's the combination that makes sense. So make sure that you have evaluated the need to have additional sensors or channels of measurement in the instrument if you have something else that is a concern. Sometimes it's SO2, sometimes it's NO2, sometimes it's cyanide, sometimes it's ozone. It can be just a wide variety of different analytes and contaminants. So that's also on the fixed detection questionnaire, a central question. What do you need to measure? That determines everything that follows. Do you use pump equipped instruments? If you do, consider whether you're better off with a attachable pump, a separately powered attachable pump, an internal pump, or if you don't need a pump, then a diffusion design. Batteries are a major concern. I'm happy that um, um, one of our premier, most popular sensors is used to measure hydrofluoric acid, HF. Where do you run into HF? Well, if you have lithium ion batteries and you have a thermal runaway and the battery catches fire, which is a constant concern, especially with our fire service customers who deal every day with, unfortunately, with electric vehicle battery fires. You get a huge volume of HF, toxic, horribly toxic HF gas produced. That's what happens if you damage a lithium ion battery. The electrolyte in the battery is a combustible liquid. It doesn't require oxygen, external oxygen in order to burn, has everything that you need for a fire right in the battery. All you need to do is heat the electrolyte up to the auto ignition temperature and you're off to the races. The reason I mention this is GFG, we don't really like using lithium ion batteries in our instruments. We choose to use nickel metal hydride, which are not subject to thermal runaway. They're not full of a combustible liquid electrolyte, and they are not prone to catching fire, nor would the alkaline batteries that we have as an option with several of our products as well. We love packaging calibration kits or bump check kits or docking stations together with the instruments to make the obligation of testing and calibrating your instruments easy. You don't need a super expensive docking station. Well, ours is not super expensive, but you can get by with a very inexpensive small cylinder of pump gas and be fully conforming with OSHA and NFPA regulations and recommendations to perform a bump check before each day's use. But if you're following the OSHA best practice, if you're following NFPA guidelines, you really should consider packaging your instrument up with a kit that allows you to actually test according to retire requirements. If you're dealing with the instruments by checking them out of a tool room in the morning, then having a docking station in the tool room really makes a lot of sense. So before they leave the tool room, you put them in the dock, you verify the uh, instrument is fit for use, and off you go. For fixed gas detection systems, it's not a daily occurrence. You're probably going to do a full calibration on usually on a quarterly basis, or if something unusual has happened. Another issue that you should think about if you're entertaining the idea of making use of wireless communication in any instruments that you're adding to your fleet or that you're thinking about buying. Make sure you understand how that communication works and important parameters like transmission distance. If it has wireless communication, but it goes no further than a Bluetooth mouse on your laptop, that might not do you much good. For GFG, we stick with RF, license-free ISM RF. So we go a little bit further than you get with a Bluetooth device, but still there are ultimately limits. So talk to the manufacturer and make sure that realistically it's going to work in a way that does the job that you need. And finally, make sure that my advice again, make sure that you're buying from a distributor and a manufacturer where they actually believe in after the sale support. This is life critical equipment. We get a lot of questions from our customers at GFG, how to use the equipment. They'll wind up having a response where a new issue that they were not expecting comes up. They might need a replacement sensor. We don't retire our instruments. We like to keep them in service. We periodically refurbish them, replenish the sensors or replace the sensors. It makes us happy to see instruments last for 12 or 14 years. Why do you want to throw away capital equipment? I don't get it. But anyway, in order for that kind of philosophy to work, there's got to be somebody to respond when you call for help. So if you expect to need help at some time over the ownership life of the product, make sure that there's a way to contact the manufacturer or the vendor. And for a lot of this information, one of the wonderful places to go immediately is to the website for the company. In our case, that would be gfgsafety.com. Make sure that you use the /USEN in the website URL. That's a worldwide website for a worldwide company. You want to pick the data sheets and show the certifications that we have for customers in the Americas if you happen to be a customer of GFG in the Americas. And that is just about everything in my presentation. Do we have any questions, Sam? Or if we don't get to your questions right now, please send me an email. I will get back to you as quickly as I can. And again, thank you for the opportunity to go over this information. I hope it was useful.
Perfect. Yeah, Bob, we have time for about one question. As Bob mentioned, any of the questions that you asked, whether it was on the registration form or in the chat here today, we will send them all over to Bob to make sure that he has time to answer those or reach out to you personally. So the question we have here is fresh air calibration equivalent to bump testing?
No, fresh air calibration adjusts the oxygen reading to, in our case, 20.9, which is the concentration of oxygen in fresh air. That actually, for the oxygen sensor, is a span calibration. To zero the oxygen sensor, you actually calibrate the sensor using pure nitrogen, which has zero oxygen. For the other sensors, you don't have the chemical or the gas in fresh air, so you're adjusting the reading to zero. When you calibrate the rest of the sensors, when you span calibrate, you're using usually a cylinder of gas or a gas generator, and you're feeding the sensor what it's designed to measure. So if you're measuring combustible gas, you're feeding it 50% LEL, and you're adjusting the reading. When you're zeroing that LEL sensor, you're making sure that in fresh air, it shows a reading of zero.
All right, fantastic. Well, Bob, thank you so much for your time today. As everybody can see, Bob's information, his email, the website, phone numbers, it's all on the screen for you right now. Jot those down. We will send you a link to the recording to everyone probably by Monday, so keep an eye out for that. But take a note of Bob's information now so you can reach out to him. And again, I will send over all of the questions that you guys asked for Bob so that he can reach out to you or direct you in the right area. So Bob, thank you so much for being here today. I want to thank GFG Instrumentation Inc. as well as AD Safety Network for allowing you to be here today. And of course, I want to thank everybody for attending and all of the dedicated safety professionals for the great work they do on a daily basis in keeping our workplaces safe, because without you guys, none of this would be possible. So thanks again. Take care. Stay safe. Bye, everyone.
Bye bye. Thank you.